Tantalum, graphite, or silicon carbide? Which one is the best? Welcome to this webinar, which will focus on selecting the most suitable materials of construction for ultra-corrosive heat transfer applications. First of all, we will give a brief summary of the Mersen group and then review the various materials of construction which offer both high corrosion resistance and good thermal conductivity. Therefore, we will discuss impervious graphite, tantalum, and sintered silicon carbide. Mersen is a global expert in electrical power and advanced materials. It had consolidated revenues of 950 million euros in 2019, employs 6,800 people around the world and is present in 35 countries. At Mersen, our goal is to help our customers meet their technological challenges. Mersen is one of the key leaders in the fields of brushes for industrial electric motors, of high-temperature isostatic graphite applications, of the passive and hybrid devices for power electronics, of the industrial fuses, and of the current collectors devices for rail. Mersen is also one of the key leaders in the anti-corrosion process equipment industry. Mersen's anti-corrosion equipment division offers a complete range of corrosion-resistant process equipment for the most severe corrosive applications. Our graphite portfolio includes impervious graphite polyblock, shell and tube, cubic block, and annular groove heat exchangers. We also supply impervious graphite column, bursting disc, and hydrochloric acid synthesis units. Mersen offers sintered silicon carbide plate, block, and shell and tube heat exchangers together with all types of tantalum heat exchangers and vessels. Mersen can also propose heat exchangers and vessels in reactive metals such as titanium, zirconium, and nickel alloys. And last but not least, it also produces PTFE line steel pipes and fittings as well as PTFE line columns. Thanks to our service centers strategically located in North America, Western Europe, North Africa, and Southeast Asia, we ensure the prompt servicing of our equipment wherever and whenever needed. In order to provide long-lasting equipment in ultra-corrosive applications, the material of construction has to be perfectly adapted to the chemical environment. The composition of the process and service fluids, together with their temperatures, shall be carefully studied, as minor elements such as impurities, for example, can make major differences. The temperature is a key parameter, as every material and component of the heat exchanger has its own temperature limit. And finally, the resistance to heat transfer of the heat exchanger's wall depends on the thermal conductivity of its material of construction as well as the wall thickness. The thinner the wall and higher the material's thermal conductivity, the lower the resistance to heat transfer. All these parameters are essential to select the most adapted solution in an ultra-corrosive heat transfer application. Mersen offers 4 different grades of impervious graphite. Graphylor BS is a phenolic resin impregnated extruded graphite. It is suitable for most ultra-corrosive non-oxidizing applications. Graphylor XBS is a phenolic resin impregnated isostatic graphite. It contains less phenolic resin than Graphylor BS and has a higher mechanical strength and an enhanced corrosion resistance. Graphylor XTH is a PTFE impregnated isostatic graphite. It can withstand mildly oxidizing media such as diluted nitric acid, among others. Graphylor XC is a carbon impregnated isostatic graphite. This material is unique as it can withstand temperatures up to 430 degrees Celsius. Mersen also offers tantalum and silicon carbide process equipment. Tantalum is corrosion resistant against acids and oxidizing media. It is a reactive and refractory metal that can be welded. Sintered silicon carbide is a ceramic that is universally corrosion resistant. The Mersen anti-corrosion equipment division manufactures 4 main grades of impregnated graphite. They all have an excellent thermal conductivity of 130 watt per meter Kelvin. Graphylor BS is a phenolic resin impregnated extruded graphite. It contains between 18 and 25% of phenolic resin. It has a maximum design temperature of 200 degrees Celsius. It has an excellent corrosion resistance against common acids such as hydrochloric acid, hydrofluoric acid, hydrobromic acid, and sulfuric acid. It has a limited resistance against bases and oxidizing media such as nitric acid, chlorine, bromine, or hydrogen peroxide, for example. Graphylor BS is suitable for most ultra-corrosive applications. Graphylor XBS is a phenolic resin impregnated isostatic graphite. It contains much less phenolic resin than Graphylor BS. It is mechanically stronger than Graphylor BS and has a maximum design temperature of 220 degrees Celsius. It has an even better corrosion resistance than Graphylor BS against common acids. It has a slightly better resistance than Graphylor BS against bases and oxidizing media. Graphylor XBS is dedicated to the toughest but non-oxidizing ultra-corrosive applications. Mersen manufactures cylindrical block heat exchangers, cubic block heat exchangers, annular groove heat exchangers, and shell and tube heat exchangers in Graphylor BS and XBS. Graphylor XTH is a PTFE impregnated isostatic graphite. It contains only PTFE. It has a maximum design temperature of 250 degrees Celsius. It has an outstanding corrosion resistance against common acids such as hydrochloric acid, hydrofluoric acid, hydrobromic acid, and sulfuric acid. It has an improved resistance against bases and oxidizing media. Graphylor XTH is dedicated to applications with slightly oxidizing media such as nitric acid, for example. Graphylor XC is a carbon-impregnated isostatic graphite. It has a maximum design temperature of 430 degrees Celsius. It has an outstanding corrosion resistance against common acids. Graphylor XC is dedicated to high-temperature applications. Mersen manufactures both cylindrical block and cubic block heat exchangers in Graphylor XTH and XC. Annular groove and shell and tube heat exchangers cannot be manufactured in Graphylor XTH and XC since these materials cannot be cemented together. Tantalum is a reactive and refractory metal. It can be welded under a protective atmosphere. A thin layer of tantalum oxide at its surface ensures its outstanding corrosion resistance against ultra-corrosive and oxidizing chemicals, including concentrated sulfuric acid, free chlorine, and free bromine, among others. It has a limited resistance against bases and reducing media. Tantalum is not resistant against fluorides. Mersen manufactures tantalum shell and tube, bayonet, and coil heat exchangers. Sintered silicon carbide is a ceramic that has an extremely high thermal conductivity of 120 watt per meter Kelvin. It has a universal corrosion resistance. It is corrosion resistant against acids, bases, oxidizing, and reducing media. Mersen offers silicon carbide plate, block, and shell and tube heat exchangers. As a conclusion, Graphylor BS is the most economical material for the construction of heat exchangers used in ultra-corrosive, non-oxidizing applications. Thanks to its fine-grained graphite structure, Graphylor XBS brings additional mechanical strength and an even higher chemical resistance. Graphylor XTH is dedicated to mildly oxidizing applications, for example, when nitric acid is involved. Graphylor XC is a unique solution which can operate at temperatures up to 430 degrees Celsius. Tantalum is a reactive metal. A thin layer of tantalum oxide at its surface ensures its outstanding corrosion resistance against ultra-corrosive and oxidizing chemicals. Tantalum heat exchangers are used in ultra-corrosive and oxidizing applications, for example with concentrated sulfuric acid, nitric acid, chlorine or bromine. They are also widely used as vapor condensers in fine chemical and pharmaceutical applications in multipurpose plants. Tantalum heat exchangers offer a fully welded construction. Sintered silicon carbide has a universal corrosion resistance. Silicon carbide heat exchangers are used in ultra-corrosive and oxidizing applications, for example in concentrated sulfuric acid, nitric acid, chlorine, fluorine and bromine. They are also widely used as vapor condensers in fine chemical and pharmaceutical applications in multipurpose plants. Sintered silicon carbide has a universal corrosion resistance. Silicon carbide heat exchangers are used in ultra-corrosive and oxidizing applications, for example with concentrated sulfuric acid, nitric acid, chlorine, fluorine or bromine. They are also widely used as vapor condensers in fine chemical and pharmaceutical applications in multipurpose plants. As far as costs are concerned, Graphylor BS is the most cost-effective alternative. Graphylor XBS is slightly more expensive. Graphylor XTH and XSC are higher cost material that can be only justified by some specific process requirements. Finally, tantalum and silicon carbide are the highest cost, but offer perfect solutions against the most aggressive chemicals on Earth. Thanks for your attention.